So in chapter 8, what we're looking at are sampling techniques. And we're doing this not only for qualitative studies, but also quantitative studies. Now, sampling is a major issue because essentially what we're doing is we're trying to come up with some sort of technique or rationale for why we're looking at certain cases and not others in a population. So essentially, why are we picking the specific individuals or observations that we are and neglecting others? What is the rationale or the reasoning behind it? And this is what you see here, right? The population is the widest set of cases. It is the entire set of observations and or individuals. And then in the sample, what we're doing is we're looking at only a small segment of that population. So the first group of, or the first type of way of thinking about sampling would be with representative sampling. And in representative sampling, one example would be non-probability sampling. Now this is a sampling technique where basically you're using the judgment of the researcher to be the rationale behind why you're picking certain individuals or observations and not others. So first there is convenience sampling, which is kind of the easiest, laziest method, which basically just says, whoever the researcher happens to come across, in whatever accidental, haphazard, unexplained way, that's the individuals that you observed. And that's the individuals that were picked. Nothing beyond that. In quota sampling, what we're doing is we're taking a non-random sample that the researcher is identifying the categories, and then with those categories of the types of individuals that they want to talk to, what they're doing is they're trying to make sure that they have a certain number in each category. So what you see here in the figure is that I have 32 people. I want to have 10 in my sample. That would mean that I want to have, for whatever reason here, I want to have, given what the population looks like, I want to have 4 males, 4 females, and a child that's a male and a child that's a female. And then finally, there's purposive sampling. In purposive sampling, what I'm doing here is I'm actually, in some sense, oversampling the specific categories that I want to focus on. So, for instance, if I had a study that was focused on, environmental factors that lead to, cancer among males, then obviously I'm going to oversample males because there'd be no point to sampling females in this case, right? If only for comparison purposes. Now, in probability sampling here, the sampling element here is my the name that I give to the case that I'm looking at. It's the thing that I am looking at. What is it that I'm trying to study? Now, those sampling elements are taken from my population. That's all my cases that exist. And on page 246, there's actually a pretty good list of the ways to think about population. Now, population can be further understood as a target population. And in the target population, what we're doing is we're actually looking at a large group of cases, but we are concretely specifying what they are. And from that very well specified large group of cases, what we're doing is then the researcher is drawing a sample, and then making generalizations of, from that target population. In the sampling frame, what I have is all of my cases that are in my population, and I try to have a brief description or approximation of what each of those cases look like. And in the sampling ratio, what I'm doing here is it's basically looking at, if I looked at the entire population, let's say it had 50 people, well, if I sampled 25, my sampling ratio would be 50% because I looked at essentially 50% of the total number of individuals in the population. Now, the perimeter, what this is the, when I've started to look at my sample and I get some estimates from my sample, it's then me going back to the entire population and thinking about what that means for that group. So as you can see on the bottom here, right, I've got an entire population. Within that entire population, I have a sampling frame, something that limits how I'm looking at all of the individuals. And since I can't talk about the entire population, what I'm going to be looking at is the sample itself. So you can see here that the statistic, that's my estimate of what's coming from the population parameter. That statistic is actually, it's kind of like putting like a, it's kind of like a probe, or it's kind of like, I think I was also thinking of like an oil dipstick, right? Like in your car. Because you're not actually looking at the oil level in your car. What you're looking at is a metal stick that, has remnants of the oil from what was in the oil pan. Well, that's kind of like what's going on here. I've got an entire population. I have things going on in that population. What the statistic is doing is it's the way in which I can capture a little bit of what's going on in that population. Now, in the random sample here, as part of probability sampling, in the random sample, what I'm using is, it's a sample that's essentially generated by using a mathematically random technique. What this requires is that each observation within the population had an equal chance or equal probability of having been selected. The sampling error is what comes from this, and what I'm trying to do is reduce the size, minimize the amount of my sampling error. The sampling error is basically how much the sample is going to be deviating from the entire population. Right? Because I am sampling, that would mean I might be missing some observations entirely, some groups entirely. And so then to that extent, I would start to think that as my cases deviate from what the population looks like, then my sample will generate statistics that deviate from the entire population, right? If I go to the richest part of Oahu and I start asking people their incomes, I'm probably going to get annual incomes that are well in excess of, let's say, $500,000. Well, we would imagine that that average income level deviates greatly than if I were to go on the western side of the island and ask people their incomes. So there'd be a huge sampling error. Now, there are 5 ways to think about how to sample randomly. These 5 are the simple random, the stratified sample, the cluster sample, the systematic sample, and the multi-stage sample. We're going to talk about those 5 coming up here. So we start with the um, simple random sample. Now, well, as a mathematical technique, again, what I'm trying to do is have each observation having been equally um, able to have been chosen. What I could use is a random number generator or a random number table, which there is a random number table in your textbook. Or I could engage in some sampling distribution. What I would essentially be doing here is looking at the distribution of my random samples and how they exist from the population. In the central limit theorem, or CLT, that what essentially I should start seeing is that as I continually draw random samples, eventually a normal distribution should appear. And with this confidence interval, this would be basically then my range of the values, the highest and the lowest numbers that I get within my sample, within my random sample. And essentially, it would tell me how confident I can be about my population parameter. Essentially, I have more confidence as I draw more samples that what I'm actually looking at reflects the entire population. Now, within systematic sampling here, essentially what I'm doing is I'm looking at and systematically picking the kth case in a sampling frame. So that would be saying something like I pick in this example here, I pick every fourth observation and I start at the second observation. So second, sixth, 10th. Next one would be the 14th sample. In the stratified sampling, what I'm doing is, this is again a random sample. What I'm doing here is, as a researcher, I'm trying to identify the set of mutually exclusive and exhaustive categories within my population. So you can see here, if I think about a company, in this case a hospital, these are the types of positions that exist within the hospital. And then I'm taking my samples from that. And then we have our cluster sampling. Within the cluster sampling, what I'm doing is, again, as a random sample, as I'm looking at multiple stages in order to cover a wider geographic area. Now, one way that I engage in this cluster sampling is I could engage in what's called random digit dialing if I were doing, for instance, a phone survey. But this is becoming a little bit outdated, if only because no one really has landline phones anymore, so that's not really something that we think as much about than if you were thinking about this much earlier. Now, this is a very popular question. The question being, how large should a sample actually then be? It really all depends. It depends on the one side, as we just saw, it depends on how confident you want to be about whatever statistic you have. You want to be confident that you understand the entire population. But if that doesn't matter very much to you, if you can afford to be less confident, then you don't have to collect as large of a sample. But also, how large of a sample you need also depends on the characteristics of the population. So if I'm looking at individuals who are hard to contact, individuals, for lack of a better term, let's say, who exist on the fringes of society, right? Let's say I was trying to interview drug smugglers, right? I'm just picking an extreme example here. Well, that's a pretty private group, right? And they aren't going to be too happy to talk to me as a researcher. And Also, I might not even be getting truthful answers from them if I haven't known them previously and they don't know, if I don't know them and they don't know me. Well, then obviously I'm going to need a much larger sample to think a lot, to know a lot about what the population parameters look like. And also depends on your population size. What you see here is, within this table here, is that obviously the larger the population size, the larger sample size I need. But interestingly, what you notice is that the increment in which things go up is the increment is increasing at a decreasing rate. Right, that last 50,000 increase in the population size only required that I interview or sample 13 more individuals, whereas the first 50,000 took 1,160 people. So the percent of the population in my sample does decrease. Now, what appears here is a model of the logic of sampling and measurement. So let's start first with one that we sort of have looked at already, which would be the logic of measurement. Is that the idea here is that I have certain things that I want to explain causal relationships between two variables. Well, if that's the case, right, then I need to establish with measurement that these two that these two variables are moving and how they're actually moving. Now, when I look at then, if I combine that logic of measurement with my logic of sampling, combining the two together, what you see here is that then essentially what I'm trying to do in sampling is I'm trying to preserve, and this is very important, I'm trying to preserve what I think is a causal relationship in the population. I'm trying to preserve that by picking a sample where that same causal relationship exists. I'll repeat that again because that's quite important. What I'm combining, sampling, and measuring, when I'm combining the logics of those two, what I'm doing is I'm trying to establish or identify a sample of the population where I can preserve a causal relationship that I believe exists in the population. And you see that translation or that conversion from the causal relationship existing here all the way then to the right where that same causal relationship exists here. Now, the goal might not be that I have a representative sample. Now, sometimes we do need to do this, though. What we've basically have been talking about thus far is how do I build a representative sample. But if we don't need to do one, then probably what I would start to engage in is some qualitative research method. Within qualitative research, then, where I'm not trying to get a representative sample. Within that non-probability sampling here, I have purposive sampling, snowball samples, deviant case sampling, sequential sampling, and theoretical sampling. In purposive sampling, again, I'm looking at how to sample using just a range of different methods, and I'm trying to locate all the cases that exist of a highly specific and difficult to reach population. So if I'm looking for drug smugglers, I'm going to do everything I can to find drug smugglers. Now, In my snowball sample here, now this is again a non-random sample, and essentially what I'm doing here as a researcher is then I'm beginning with one case, and then as I start to gain information about the relationships between variables and who individuals know, then I repeat the process again based on other people that the person knows. And this is what you see to the right in this picture here, right? Is that I get to know one individual and they say, and Donna says, oh, hey, did you think about, did you think about talking to Dennis, right? And then I talk to my friend Mohammed, who leads me to Paul, who has two other friends. One of them has another friend, right? And so it's snowballing. My sample keeps getting larger and larger as I keep talking to more individuals and learning more things. In my deviant case sampling, again, non-random sample, but what here I'm doing as a researcher is I'm basically looking at the unusual or non-conforming cases to get more insight about why they are unusual or what is going on that makes them so different than the others. In sequential sampling, non-random sample, but here as a researcher I'm trying to find as many relevant cases as possible. Now, the difference between sequential sampling and purposive sampling would be that in sequential sampling, my population isn't necessarily difficult to reach and is not as specific. And then finally, in theoretical sampling, non-random sample. And then essentially here, the researcher, based on their own study, based on what they have, what the theory tells them, is then picking their locations, picking the things that they will sample. In adaptive sampling, what we're doing here is we're looking for a hidden population. And we're going to try to do lots of different things to try to identify and recruit members of this hidden population. So depending on what your research project is, you might be dealing with a group that remains largely hidden from the rest of the world. And that's our last definition then. In the hidden population is I'm looking for individuals who are engaged in the secretive things or socially disapproved things. People who are difficult to locate and study, right? So if I was looking for, I don't know, if I'm looking for, people who, I don't know, people who steal cigarettes from 7-Elevens, right? That would be a group that, because they're doing something that's socially disapproved, that they are probably going to be, I'm going to have to find ways to sample them adaptively.